Term and short term. Yes, we're going to look at both today. So short term, today we're doing a lab. Tomorrow we're going to have a class discussion about standing waves. So that will be the one day for this unit that I'm actually going to lecture in class and work on problems and stuff like that. Wednesday we've got a demo and a lab to do, and that's one of folks' favorite labs, so I'm looking forward to that. Thursday we're going to review, and then Friday we will test over waves. Okay, it's kind of fast, but if you've been following along through those days of cold, then you should be okay. If you haven't, then you need to buckle down and do that. We are going to test on Friday. I did look at our calendar to see where we were, kind of compared to where I had set us out to be over winter break. And if we can get our test in by Friday, we will only be one day behind, which is pretty awesome compared to where, I thought we would be, because we did a bunch of that stuff on your own. So I really want to shoot for that, because I don't want to fall any further behind, because even though we have, snow days and cold days and all of that, the AP test does not move. Okay? Questions about this before we go forward? Okay. So I want to, when I was going through and getting the sound lab ready, I came across this chart that I was like, oh, that was really good. I really liked doing that with my students when I didn't have a string of cold days, blah, 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 blah. But I thought it might be helpful for you. So this is not required. You're not going to turn this in. But I found this very helpful, and my students found this very helpful to help organize the Doppler effect situations. Okay. So what I'm intending for, and we're not going to go through it, but on that review day, whatever day that is on Thursday, if you want to go through it then, I'm super happy to do that. But I want you to kind of work through it as you're reading or reading in your book, watching those videos. So what happens to the sound? By that I mean the pitch. What happens to the light? By that I mean the color. Okay? And then in this situation, if you've got the source not moving and the observer not moving, is there a change in, do you guys know what this is? Wavelength. This is the letter lambda. You need to know that. So if you haven't marked that before, that's lambda. That's how you spell it in Roman letters. Shh. But it's the Greek letter lambda, and it does stand for wavelength. That is what we use to mark wavelength. Okay, so tell me what happens to the change in wavelength. How does that affect the frequency? And then you can draw yourself a little picture. I like this because it puts it all in one piece together. Okay? For the AP Physics test, you need to know the conceptual. I believe, if I read it carefully, you guys can double check and make sure I didn't make a mistake, but I believe you don't have to do the actual mathematical, let's figure out how the frequency actually changes. All of that is in your book, so if you're interested or you want to kind of see where it comes from, you're welcome to do that, but the conceptual is what AP Physics requires of you. Okay? Does that make sense how you might approach this chart? Okay, so do with that what you will. Hopefully it's not recycle it. I would strongly recommend that you use it, but again, I'm not going to collect it from you. We can talk about it at the end of the week if you would like. I would like to quickly go through this page. So this is the green one that you have in front of you as well. You listened to, read about, understand thoroughly now, I hope, the concept of superposition. What is superposition? What does that mean? Go, Jasmine, what you got?
When two waves are traveling on the same medium and they meet, the resultant wave is going to be the sum of the amplitudes.
Absolutely. Yes. So waves can occupy the same space at the same time, and superposition is what happens when you've got two waves, like you were saying, traveling through the same medium and meeting, and we're going to find out what happens. So I have 3 examples here for you to kind of give a sense of what's going on. So I've got 2 waves here. The first thing that it asks you to do is to determine the frequency of the wave, okay? And then to draw the resultant wave. So here's one, here's the other, and then you can just draw a line down here and draw a resultant wave, okay? And then describe the effect. What happens there? I'm going to give you maybe 1 minute to do all of that right now at your table. Go. We're going to keep cruising, because if we don't, we're not going to have enough time to do everything we need to do today. So help me out here. What was the frequency of the wave? 5 hertz. How do you figure that out?
I counted.
You counted. Counted like the peaks? Yeah. So from here you go 1, 2, 3, 4, 5, that's 5 cycles in 1 second. So 5 hertz. Absolutely. How about for the second one? What was the frequency of the second wave? Same? Same thing. Awesome. All right. What does the resultant wave look like? It's a big wave, right? Yeah. So we're going to take the amplitude here. We're going to add it to the amplitude here. So the amplitude on this one is going to be, holy cow, it's going to be really big. What about when you get to here? The green dot.
It's still at 0.
It's 0. 0 plus 0 is 0, right? So we can go to 0, and then it's going to be really, really little or really, really low. And then middle, and then high, and then middle. Let me see if I can get this right. I didn't. 1, 2, 3, 4. 2, 3, 4. Oh, I screwed it up. But you get the idea, right? It's going to be really big. Does the frequency change? No, it does not. The frequency does not change. That's a good thing to notice. What does change? The amplitude does.
Are you doing the whole thing or just the thing?
I just did a little bit and I messed it up anyway, so you get the idea.
Yeah.
All right, if you haven't started the next one, go ahead and do that one. Same questions. Same questions.
On the second. Infinite hertz.
Oh, the second one.
Wait, did that count right? Aiden, did that count right?
You got add.
All right. How are we doing on the second one? That one was easier to draw?
Oh wait, sorry. 6
No, it's 6.
What?
How are we doing? Well, so you need to, you're counting the number of cycles. So how many cycles did it do? So that would be 1. Yeah.
I'm sorry, I couldn't hear this on you.
Seriously.
No.
I am
Oh, they're not. They don't.
every
And you guys need to be kind also.
Yeah, I'm confirming what we are doing.
Okay, like seriously, I don't care. I do care if you're not kind, but I care a lot more if you're not. Like, you know what I'm saying? Like if you're like not kind to each other out there, it makes it sad. And we need to happen. Okay. All right. So, is this the same as the first one?
No.
Is it the same as the second one?
No.
It's a little different, right? Which kind of makes sense because if you still give me another one that's the same. What's the frequency of that first wave?
5 hertz.
5 hertz. Talked about the second wave. 6 hertz. So now you've got 2 waves that are a little bit out of phase, or excuse me, a little bit different frequency. They start out of phase, don't they?
Yeah.
So what's the resultant frequency, or excuse me, what's the resultant amplitude going to be right here at the very beginning of the story?
0.
0. Oops. Now let's take a look though at this where this dotted line is. Let's just kind of keep stuff simple here. What happens here? Now we've talked about this as superposition, but there's also another term that you hopefully already know, but I'm just going to put it out here real quick, and that is constructive and destructive interference. Okay? Constructive and destructive interference together are superposition. It's the same thing. 2 terms that mean the same thing. So, right here, based on what you know or the context clues that you have, Would we describe this first dotted line as constructive or destructive interference? Destructive, because they're smashing each other down, right? There's one high, one low, 0. Talk to me about here. That's constructive. So instead of smashing out, they're going to be double big, right? It's going to be like, holy cow, woo! Way down there. How about at this next dotted line? 0, that's destructive interference. We're using good physics terms, right? Talk to me about this dotted line. That's really, yeah. And then next dotted line? 0. Now, question for you. Does that mean that this wave just goes like this? No, it does not, right? It does not mean that because technically in order to do this, we would have to add them up at every line, right? Or get a bunch more dotted lines so we can put them together. Right. So I'm not going to make you do that right now, mostly because we don't have time, but also because it's kind of tedious. But I'm just going to show you what it looks like. So this is where it comes from originally. I just took the numbers off. So here you've got your 5 hertz wave, and you've got your 6 hertz wave. So you've got your 2 different frequencies. When you add them together, this is what it looks like.
Whoa.
Right? It's pretty, huh?
That's pretty loud.
That's pretty cool. So you can just kind of, sketch it out. You don't have, doesn't have to be perfect, but sketch that out so you've got the idea. Okay?
It's not like you can't figure it out.
I don't know what this is.
Doesn't make you better than
So the things that are important, to pay attention to are that you've got small amplitude, big amplitude, small, big, small, right? That kind of overall thing. But you've also got the oscillation that gets bigger and smaller and bigger and smaller and bigger and smaller. You with me? So there's a lot of complicated stuff that's going on here. But this is really what happens. All right? I'm going to have you put your pencils down in about 15 seconds. So draw what you can in 15 seconds. Okay, so go ahead and put your pencils down so I know your attention is up here. I want to show you something real quick, or more accurately, have you listen to something really quickly. Do you know what this is?
My dad has one of those.
Yeah? This is a tuning fork. This is a tuning fork, and today you guys are going to get to interact with some tuning forks. Not this huge one, though, because I only have 2 of them, and there are a lot more of you, but I have a bunch that are back here. I'm going to give you the spiel about these tuning forks in a little bit, but right now I'm just going to come grab one. So this is a tuning fork, and I can strike it, and if I put it up to your ear, can you hear it? Yeah, what does that, you know? Oh, he's like, I'm a percussionist, I don't know that. Okay, if you strike it, you can hear it, and
I can't hear it.
because everybody's so loud. Actually, it's not. It's because it's just vibrating a little bit, and it's vibrating, so it's and it's going to your eardrum. That's what's happening, okay? So it's vibrating back and forth, but you can't hear this because there's not a lot of space for it to resonate, right? It's just going into the air, and that doesn't push very much. The thing that I like about this is that it's just a big version of this, okay? And it's not actually the size of it that matters, it's the box. Because when I strike the box, now you can all hear it. You with me there? Okay, so this is a tuning fork. These are actually the same note. This tuning fork vibrates back and forth and back and forth and back and forth 256 times every second. Let me say that again. 256 times every second. So this was designed and made such that it would vibrate exactly at that frequency. You remember we did some harmonic motion stuff before, right? And so you got that K value. They do that exact same thing with the material to figure out how big does it need to be, how wide does it need to be, so that it will have the frequency that we want, okay? So 256 times every second, that's middle C here, and that's the same note is being played here. This one's just bigger, and it has this resonance box so that you can hear it, because it's not only pushing the air right here, but it's pushing the air in here and bouncing around, which is why you can hear it. So that's really nice. So 256 times every second, okay? So that's all well and good, but why do I care? I really care because of this, because I got that one tuning fork, and I got this one that I call the Franken fork because it's got these little things on it, okay? So if I take these off, this tuning fork and this tuning fork will play exactly the same note. 256 times back and forth and back and forth and back and forth every second, okay? But you know, because we did this in simple harmonic motion, that if I add a little mass, that's going to change the frequency. Are you with me there? Yeah? Increase the mass, it's going to change the frequency. So what I'm doing here is I'm not changing it by like 50 or I'm not changing it by 100. I'm just changing it by a little tiny bit. And the reason that I'm doing that is just like this had a 5 and a 6. We're going to change this by just a little bit, and then we're going to listen to see what happens. Now, my music friends are either going to be really, really excited about this or really, really angry with me. It's kind of a 50-50 shot depending on your attitude. And if you're not a music person, you're like, oh, that's weird. But either way, it's all good. So I haven't actually tested this today to see if I have adjusted it well, but we're going to give it a shot. So here we go. So this is 256. This is close to 256. Do you hear that?
I like it.
That's exactly what this is. Are you with me there? So that wah, 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 wah is the 256 and the 258 or something like that, okay, that are just a little bit different such that you get this wah, 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 wah thing. Is that making sense? Okay, so now that you've heard it and now that you've done the math, we're going to actually see it. So you will have an opportunity today to see this in action.
See it?
Yeah.
You see waves.
Oh, yeah.
We're seeing sound. I can see sound.
No, we literally learned that.
Oh, I can
That's
see
the
sound.
first thing. My notes were. Yeah, because that's insane.
Next, we're going to hear color.
I mean, we call it Jimmy Kirby now, so.
All right. So, friends, you've had a moment to decompress. Now it's time to stay back and stay focused because we don't have a lot of time. So I want you to take a look here at a couple of things. There are two parts to this lab. The first one is to get the concept, understand the concept of seeing sound, as Isaac so thoughtfully put it, okay? So you and your partner are partners, are going to take a Chromebook and set up your microphone just like we did last time, okay? Same equipment for that part, okay? And then you're going to strike a tuning fork with a rubber mallet. Now, I need to be very clear on what's happening here. These tuning forks are only 1 year old, right? We can count because we know when we purchased them, okay? They were all manufactured to be exactly the right frequency. What could change their frequency?
Hit them against.
Bending them, hitting them, doing anything to them that changes their shape. Are you with me here? Okay, so you need to be exceedingly careful with them. Okay, so I've got the tuning forks over here on a little pile of papers, just so that they're not going to get slammed up. Please be quiet and please listen. Okay, over on this piece of paper, I've actually got them organized by frequency as well, so that there are two of each. When you come over and pick them up, I also want you to pick up a piece of paper so that you can set it down on the paper. Are you guys listening? Because there's a lot of talking and it's not going to work for me. Okay, please listen. So you're going to set them down on the paper instead of on this hard table because the hard table could nick them and that would cause them to change their frequency. And in this lab, the first thing we're doing is trying to measure their frequency. Does that make sense? So you want 30 years from now, the AP Physics students that are sitting here to be able to measure with these tuning forks as well. Got it? Okay. So you're going to get tuning forks. You're also going to get rubber mallets. You should only ever strike the tuning fork with the rubber mallet. And by that I mean with the rubber part of the mallet. So you can kind of hear that, right? Like that one's a little high-pitched one, right? But you can hear it. It's a different sound if you accidentally hit it with the Now, I know that might happen, but the thing that I want you to do is, number one, be careful and make sure to strike it with the rubber part of the mallet. And number two, if it strikes with the plastic part, then just dampen it really fast. Just put your fingers on it, and then it'll be okay. Does that make sense? So just be careful with them. That's really what I'm asking, is to be careful with the equipment. And then just set them down. When you're done with it, bring it back so that somebody else can use it. Does that make sense? I don't have enough of them for everybody to have a set. So, you're going to, guys, you're going to strike the tuning fork with the mallet. You're going to hold the tuning fork close to the microphone. Please stop talking. You guys can figure it out in a minute. Please stop talking. You should get data that's sinusoidal in form, so it should look something like that, okay? If you strike the fork too hard or too soft, it might look yucky. Just like last time, try again. It doesn't, like, you can get it. I know you can. Repeat a couple of times. Look how the wave changes if you get it loud or softer. Probably you can predict it, but I want to make sure you've seen it. You want to find data points to determine the period, okay? Because this is measuring pressure over time, so you should be able to find the period. Yes, okay? I want you to complete 3 trials for each of 2 tuning forks. Make a data table on, it says right here, separate sheet of paper. Underline it right now if you need a reminder of that, okay? Based on the average period, calculate the frequency, and then compare the frequency with the frequency that's marked on the fork. Everybody needs to do one, okay? Now, once you finish that, and that should not take a long time, there is a back, and the back's the more exciting part, so take a look up here. Please stop talking. You will get to see some beats. So here we heard the beats. Wah, 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 wah. We want to actually see that happen. So you're going to take 2 tuning forks. You want tuning forks that are the closer to the same frequency, the better, but don't take like 2 512s. Because if you take 2 512s, then you're going to get hopefully no beats, right? So take like a 512 and a 480. Those would be close to each other, okay? This part here, it's kind of, I equate it to like Wolverine. So you're like kind of enacting your goal to be Wolverine at some point. So you take one of the tuning forks like this, put the other one like this, so you can hold them at the same time. Does that make sense? I found that it's easier to have one person do both. If you want to have 2 people do them and try it out that way, that's awesome. But it seems to work better this way, and then you're going to have somebody strike and strike, and then you're going to put the microphone right in between. Okay? And then you'll be able to see the waves. Okay?
You don't have to.
Nope. Yeah. And sometimes you have to try it a few times. So it might not be perfect. Like you might have to, you might have to like try it, 2 or 3 times. But you'll know because you'll see that wah, wah, wah. You also may need to change the time that you're looking at it. Okay? The amount of time that you're collecting and the size to be able to see it. But you should be able to get to see it. Okay? You're going to compare that theoretical frequency with the actual or your measured. And you're going to calculate percent error for that as well, okay? You should have time to get all of this done in class today. That is my goal and hope for you, okay? You can work in the same groups as you did last time, or you can work in different groups. Does not matter to me. Go, go, go.
I'm not ready. We need 3 different